Hello and welcome back to the channel Understanding.Concepts.Of.Physics. Hope you all are doing well. In case if you are new to the channel, just please subscribe the channel so that you can follow up the updates. We have been doing kinetic theory of gases as of now, and in the last video we had discussed three numericals of KTG, kinetic theory of gases. And in today's video also we are going to discuss three more numericals on kinetic theory of gases. Let's quickly start the video, and in case if you are not following anything, I would request you to go back to previous videos and just go back to the previous video and have that lectures. So today's video is today's first numerical is based on this first proof. If you can see on the screen, you can just pause the video and read the question. Show that RMS velocity of an oxygen molecule is √2 times that of sulfur dioxide molecule at STP. Now first I would like to highlight this STP. STP stands for standard temperature and pressure. Standard temperature and pressure. Now it implies that the temperature should be 0 degrees Celsius, which is equal to 273 Kelvin, and pressure should be 1 atmosphere, which is almost like 1.013 into 10 raised to 5 Newton per meter square. So we generally put 1 atmosphere. Yes, you can also put in Newton per meter square if there is a requirement of SI systems. So we are supposed to prove that the RMS velocity of oxygen molecule is equal to √2 times the RMS velocity of SO2 molecules, that is sulfur dioxide. Now there is no mention about the molar masses of both of these gases, neither oxygen neither SO2, and so we are supposed to find out the molar masses according to our concepts. So in order to find out the molar mass, let's say for oxygen, I would work on here, or oxygen. Now in order to find out for oxygen, what we do is let me change the color. Okay, oxygen. Now I'll find out where this oxygen lies in my periodic table, and it lies at 8. So it has 8 number of protons inside its nucleus, and it will also have neutrons, and that will also be 8. So there is 16 nucleons. This is called as nucleons. So 16 nucleons in all. But oxygen, if you see oxygen is a diatomic gas. It's a diatomic gas. That means one atom will contain 16, and the other atom, which will constitute a molecule, will contain 16. So 16 for one and 16 for the other. So you will get 16 plus 16. 16 plus 16, that is equal to 32. So oxygen comes out to be 32. Now similar manner, if I do it for SO2, as it contains O2, it will have 32 of oxygen. Now if you consider sulfur lies at the number 16. So it has 16 protons. For sulfur there are 16 protons and 16 neutrons. So that will constitute 32 nucleons. So this is for one sulfur, and our oxygen has 32. So SO2 will constitute 32 for oxygen and 32 for sulfur. So that will come out to be 64. Now this is a basic calculation for finding out the molar mass. Yes, we can find out for other gases as well. And let's see, going back to the same question. Now, so CRMS is equal to square root of 3RT by M0, where R is the universal gas constant and its value is fixed, 8.314 joules per mole Kelvin. Its value will not change. T stands for temperature and M0 stands for the molar mass. So I have found out the molar mass for both of these gases. Let's see. STP stands for standard temperature and pressure. Temperature is 0 degrees Celsius, pressure is 1 atmosphere. Temperature is basically 273 Kelvin. Now I am not taking 273.15 Kelvin. I am ignoring this 15. For basic calculation we can just ignore those aspects. Then CRMS, if you see the temperature is not changing, so that means the CRMS is only depending on M0, because 3 is a constant and R is a constant and temperature itself is a constant as they have mentioned it. So that means CRMS will only depend on the molar mass. So I have just manipulated my formula. CRMS is inversely proportional to the square root of the molar mass. With this equation I am going to create two equations, one for oxygen and the other for sulfur, SO2. So CRMS O2, that is for oxygen, is equal to 1 upon square root of M0O2, that is molar mass for oxygen, and CRMS SO2 will be 1 upon square root of M0SO2, that is molar mass of sulfur dioxide. Now this is the denominator's denominator, we'll just move it up, so I'll get that's A upon B upon C upon D, that would be A upon B into D upon C. So the denominator goes up, so M0SO2 goes up, this goes up, and M0O2 remains in the denominator. Now let's fill in the values. This is 64, this is 32, so I'll get 64 upon 32. 32 ones are, 32 twos are, so I'll just do it with a different color. We'll do it with a white. Okay, so 32 ones are, 32 twos are, so I get root 2. And then lastly I'll just take this on the other side, so I'll get CRMS SO2 on the other side. So CRMS SO2 on the other side, what remains is root 2. So CRMS O2, that is oxygen molecules RMS velocity, is root 2 times CRMS of SO2. That's what we are supposed to prove. So this is our first numerical of the day. We are going to do two more based on similar concepts. Okay. Now I would like to pause, I would insist you to pause this video and have a go at this question. The question is very simple. Again, with the same formula we'll be solving this. So they are given two gases, and one is oxygen and the other is helium. There are two gases and they are saying same RMS speed, that is RMS speed is same. So there is oxygen, there is helium, and they have also given the molar mass and molar mass for oxygen and helium. So in case if they didn't give us, we would have easily found out. And they are asking what is the temperature of oxygen, temperature of oxygen. However, helium is at STP, that is 0 degrees Celsius. So at what temperature the RMS speed would be same? Okay, the answer has to be coming out to be this. Let's see. So I have deduced that data into a tabular form. Oxygen is given, if you see the data, oxygen, helium, molar mass oxygen, molar mass helium. So I'll just put a suffix over there. This is MOO2 and this is MOHE, that is for helium. Okay, then temperature of oxygen is unknown, temperature of helium is, they are saying STP. STP means 0 degrees Celsius, that is 273 Kelvin. And they have also given that RMS speed for both of them would be same. Let's go ahead. So we are supposed to find out TO2, that is temperature of oxygen, at which both the molecules will have the same velocity. So I'm using that basic formula, that is CRMS is equal to square root of 3 RT by M0. Now here the R is constant, 3 is constant, but temperature is not, and neither is M0. So my CRMS depends on square root of T by M0. Because T was constant in the earlier problem, we didn't write T in earlier problem. Okay. Now with this equation I'm going to create two equations. So one for oxygen and the other for helium. So RMS velocity of oxygen and RMS velocity of helium. Square root of, if you see there is O2 here, and there is a helium here and there is a helium here. So I have created two equations out of this and I have divided them. I have taken a ratio. Now because they have said that these two quantities are same, I will cancel this out. So let me cancel this with a white. Okay, so these two cancels out and what remains is 1. So 1 is left out. Now I can take this square root under a single radical sign. So this is called as a radical sign, and we can just take that into a single root. So I have taken a single root. Then again, here the same quantity is used, like if it is a denominator's denominator, this is going to go to the numerator and this is going to go to the denominator. So MOHE goes to the numerator and THE goes to the denominator. These quantities are same as it is. Now TO2 is something which is not given. MO2 is given as 32. Helium molar mass is 4 and temperature of helium is 273. Now remember that the temperature should always be in a Kelvin scale. Now somebody would wonder, okay, where is this root going? Now I have just squared on both the sides, so 1 square is 1, so that is 1, and square root of square root and the square of that will give me without a root, so there is a no root over here. Okay, now I'll taken this 32 and 273 on the other side, so this goes on the other side. So 32 into 273 goes to the numerator part and this 4 comes to the denominator, so that's divided by 4. Then I've cancelled 4 ones are, I'll do that with a white. 4 ones are and 4 eights are. Okay, and what remains is I get 8 times 273. If I multiply that, I'll get 2184 Kelvin, which is the required answer. So this marks the end of our second question of the day, and now we are going on to the third. Now in the third question, if you just pause the video and go through the entire question, you will find out you are given with two gases, again hydrogen and there is oxygen, and hydrogen is at 127 degrees Celsius. Yes, we'll have to convert that into Kelvin, and oxygen is at 27 degrees Celsius. We are supposed to move that into Kelvin, and the molar masses of oxygen and hydrogen is also given, and the answer should come out to be 8 is to root 3. Let's see. Now I'll represent the data into a tabular form. So I have a hydrogen here, I have an oxygen over here, and temperature of hydrogen is given as 127 degrees Celsius. I need to convert that to Kelvin, so I'll just add this 127 plus 273. I'll get 400 Kelvin. So this comes out to be 400 Kelvin. And temperature of oxygen is given as 27 degrees Celsius. I'll have to convert this into Kelvin. So 27 plus 273 will give me 300 Kelvin. So that's 300 Kelvin. Molar mass of hydrogen and molar mass of oxygen is given, not a worry. And they are said to find out the compare. They are supposed to find out they are asked to find out the ratio. So CRMS, RMS velocity of hydrogen and RMS velocity of oxygen molecule. This is something they are asking to find out. Again, the same formula will apply. CRMS is equal to square root of 3RT by M0. The same formula. Now, in this question as well, 3 is a constant, R is a constant, so we are going to ignore this while we take the ratio. Temperature and molar mass is something which is variable. I mean, they have given there are two temperatures and there are two types of gases. So CRMS is directly proportional to square root of T upon M0. Now I'll create two equations out of this one equation, one for hydrogen and the other for oxygen. So if you see hydrogen, this is oxygen. Now this is denominator, I'll take this up, this goes up, so M0O2 goes up and T0O2 remains downstairs. These two quantities as it is. Now temperature of hydrogen is given as 400, molar mass is 2, molar mass of oxygen is 32, temperature of oxygen is 300. Now the best part is about the cancellation. So 0 0 cancelled, 0 0 cancelled, and I get 2 ones are, 2 twos are, and 32 twos are is 64. So I will get 64 in the numerator and 3 in the denominator. Okay, so I'll just clear this off. That's just basic calculation part. Now when I take 64 outside the root, it becomes 8, and 3 is not a perfect square, so it will remain root 3. So this will become CRMS H2 upon CRMS O2. In the form of ratio, I can write it 8 is to root 3. Now depending upon which board you are, you can just go through and calculate this part. In case you are in a board where calculator is allowed, this is just a piece of cake. Otherwise, in case if you are not allowed, then you can solve it multiple ways. So I can even rationalize this. I'll multiply this by root 3 and divided this by root 3. So I get 8 root 3 upon 3. Now I'll cancel this 3 ones are and 3 somethings are, and root 3 ka value I can put always as 1.732. In case if your board demands logarithmic calculation, you can just apply logarithm and you can get a perfect value. But anyway, this is what it is. Like majorly what conceptually things are sorted. Just one thing, like if you are worrying about how to find out the molar mass in case if the molar mass is not given, again I would again go back to the same thing. If I want to find out regarding hydrogen, hydrogen stands at the first place. It has a single proton and it does not have a neutron. It does not have a neutron. So this is 0 neutron. So the number of nucleons is basically 1. But hydrogen is a diatomic gas. It's 2 atoms combined to form 1 molecule of hydrogen. So that would be 1 plus 1, that would be 2. So molar mass of hydrogen would be 2. Same way if I go for helium, helium stands on second in the periodic table. So it has 2 protons and it has 2 neutrons. And this will make number of nucleons as 4. Now the speciality of helium is a monoatomic gas. It's a monoatomic gas, and this was a diatomic gas. Now what is mono and diatomic gas? I have pretty detailed explained in one of the previous videos where we had found out the specific heat capacities. So you can go and watch those videos. And so molar mass for helium is, that's why 4. So these are the few. You can just check it for yourself. For nitrogen comes out to be 28 or no, whether you get nitrogen as 28. And you can just check for H2O as well, and there are so many molecules which you can test for. Okay, just go ahead and you can comment for H2O, what H2O molar mass for H2O would be. Okay, so winding up for today. Thank you so much for watching. In case you haven't subscribed my channel yet, just please subscribe this channel, keep following. And I'm again and again telling people have been watching the videos but they are not subscribing. So I would like to again highlight that please subscribe the channel. Also, in case if you are not following any of the part of the videos, then I would highly request you to go back to the previous videos and study the theory lectures and come back to the video which you haven't understood. Thank you so much. Goodbye.